We're going to take a look at the areas of trapezoids and kites. The formulas are given to us in the textbook by theorems, but I'd like to actually show you how that's constructed. Let's begin by constructing a trapezoid. A trapezoid, by definition, is a quadrilateral with one set of parallel lines. Now I'm going to make this quadrilateral irregular. In other words, not an isosceles trapezoid, because I really want you to understand how this formula is constructed. So if I take the midpoints of each of these segments, and then I construct an altitude at that moment, I can take this triangle here and rotate it so that it fits up there. So basically what I did is I cut off this triangle from here and I flipped it up to there. I can take this triangle as well and rotate it 180 degrees and flip it up there. At point C there is a right angle. You also have a right angle down here. Vertical angles are congruent, and then I made this the midpoint, so we have a congruent side. So by angle, angle, side, these two triangles on both sides, even though they're different shaped triangles, this brown triangle here would have been congruent to this triangle down here. This gray triangle here was congruent to this triangle here. So now essentially what I've done is create a rectangle. And the base of this rectangle is the length of that median. That measure there is the average of these two bases, and then the height remains constant. The book is telling us that the area of the trapezoid is the median times the height, which we just saw in the sketch pad. We know that the median is the average of the two bases, and then if we look at the original formula that they gave us, the average of the two bases is seen right there, and that's times the height. We can do a similar demonstration for the area of a kite. Here the theorem tells us it's 1/2 of one diagonal times the other. So I'm going to construct some random kite. Come on. Sorry, construct a perpendicular line. And, well, may as well pick those. There we go. There's my kite. So now I can hide that and that and that, and I'll draw in this diagonal here. So now what I can do with this is notice that this triangle here is congruent to this triangle here. So I can take this green triangle. I think I'm going to do two transformations and reflect it across there. So now you can see that they are indeed congruent. And then I'm going to do a rotation oops, not a reflection, a rotation of 180 degrees. Sorry. So now I've taken this triangle and flipped it up here. I can repeat the process with this triangle. So you can see those are congruent. Mark that as the center. And then rotate this 180 degrees as well. And now, do you see the rectangle? Where one measure is half of one diagonal and the full diagonal of the other is the length. So the width or the base is half of one diagonal, the length or the height is the other diagonal. In this example, you're given diagonals of 9 and 14. Half of 14 is 7, then multiply that by 9, you get 63. Recall that a rhombus is a kite. So if we're given the diagonals, xz is 8, and xp is only 4, well, that makes sense because the diagonals of a rhombus bisect each other, so they didn't need to give us both pieces. And they tell us that the side is 5, or the perimeter is 20, so the side is 5. Then we can see this is a 3, 4, 5 right triangle. And we know this diagonal would be 6, the other one's 8. 6 times 8 divided by 2 is 24. If we're giving a trapezoid with a height of 7, lower base 18, upper base 12, 18 plus 12 is 30, divide that by 2, our median is 15. 15 times 7 is 70 plus 35, or 105. We have to find the shorter base of a trapezoid if the area is 52. Remember, the area is the average of the bases, which is the median, times the height. So they're telling us the area is 52. One base is unknown, the other one's 10, and the height is 8. So half of 8 is 4. If I divide both sides by 4, then I get 13 equals x plus 10, and x equals 3. Here the height of the trapezoid is 12. We have to find the median. 6 plus 4 divided by 2 is 10. 10 times 12 is 120. If the trapezoid has bases 7 and 9, the median is the sum of that divided by 2, or 8, and the height is 5. So 8 times 5 is 40. If the height of the trapezoid is 12 and the area is 120, one base is 7, find the length of the other base. So here we have area equals 1/2 base 1 plus base 2 times the height. 120 is equal to 1/2 of x plus 7 times 12. Half of 12 is 6. So 20 equals x plus 7. 13 equals x. A straight wire stretches between the tops of two poles whose heights are 20 and 12. Find the height of the pole that is to be placed halfway in between to support the wire. Well, if these are all perpendicular, then these are parallel, and the 12 and the 20 are the bases of a trapezoid. So 20 plus 12 divided by 2 is 16. Find the total area of the figure shown. CD is 25, BC is 10, AB is 5, AG is 26. That's an isosceles trapezoid. And on top is an isosceles triangle. So now I have to take the area of the triangle plus the area of the trapezoid plus the area of the rectangle. The area of the rectangle is going to be the easiest for me to find at this point. I know opposite sides of a rectangle are congruent, so that's 26. And if that's isosceles, I can drop down some altitudes here. Oh, I forgot a figure. I forgot to label CE as 14. So if these are perpendicular, then this inside measure from there to there is 14. 26 minus 14 is 12. And that would need to be divided equally there. So that's a 6 something 10. Means that height is 8. So the area of that trapezoid is 1/2 the average of the bases times the height. And the area of this triangle is going to be 1/2 of 14 times the height, which we still need to figure out. It's isosceles, so the altitude is also the median. So that's a 7 something 25. 24. So that's 168, 160, and 130. Now I have to take the sum of those three parts. So I get 8, and 6 and 6 is 12, plus 3 is 15, so that should be 458. Find the area of a kite with diagonals of 10 and 5. Remember that the area is 1/2 of one diagonal times the other. So half of 10 is 5, 25. Find the area of a rhombus with an altitude of 6 and a side of 5. Remember that a rhombus is both a parallelogram and a kite. In this case, I would use the formula for parallelogram, so it would be just 6 times 5, or 30. What you're looking for is two perpendicular lengths. If that side's 5, so is that. Find the total area of a rhombus with a perimeter of 40, so that means the side is 10, and an interior angle of 45 degrees. So if this is 10, then this would be 5 root 2. So we would have, I would again use area of a parallelogram, multiply those two numbers, and you get 50 root 2.